Welcome to the series of CephFS Code work through talks. In this talk, I'll be talking about MDS part traversal. So before getting into the MDS part traversal, let us get to know the data structure that it deals with. There are three important data structure that it deals with. First being the C inode, seed entry, and the seed. The C here refers to the cache. So C inode is per file. So as we all know that an inode in a file system represents the file, and it contains the information like who owns the file, attributes, and other stuff. So it's similar here as well. And seed entry is the short form of directory entry. So the directory entry glues the inode and the file name or the path or the directory name. So as you can see that the seed entry links at most one C inode, and an inode can have be linked to the multiple entries. So that is the use case with respect to the hard links. So when hard links are involved, we'll have a single inode linking to the multiple entries. And CDIR is a data structure. It exists only for the directories. So it is used to link the entries under the directory. So we'll get to know more about it when we look into the code. We'll have more understanding about it. So these are the three important data structures. And also we have the concept of authoritative MDS. So any particular inode should be if it is being changed by particular MDS, so it should be authoritative MDS. So if it is not an authoritative MDS for that particular inode, usually if it will forward the request to the authoritative MDS. So we have this concept. So and now let's get into the. I thought first we'll go through the path traversal code, and after that I thought we'll discuss three use cases. One being the what happens when we touch a file in a particular path, and the second use case being what happens if the path involves the snap directory, and third simple use case where if some entity doesn't exist in the path. So there are other complicated use cases. In this talk, I'll be considering only the single MDS use case, but there are other complicated use cases involving multiple MDS, and if that particular directory entry falls into the different MDS, what happens and all the stuff. I'll be touching those concepts theoretically, but I'll not be going through them with the GDB and stuff. In these three use cases, I'll go through with the GDB and show you and print the structures and how does the code flow. So now let's get into the code. Okay, so the MD cache object defines the path traversal routine. So the path traversal.
Kotresh, can you increase the font size, please?
Yeah. Is it better?
Yeah, this is good. Yeah.
Okay. So the MD cache object defines the path traverse routine. So the path traverse basically it takes the file path, and the return values, as you can see, would be the vector of the entries and the inode of that particular base name component. So when we attach GDB and C, it will be more clear, but this is what it does, and it also comes with the MD request structure. So the MD request structure maintains the context of the request with respect to the is there any previous request that is in process. So all these states are maintained, and it validates. It is useful to validate and get through the MDS code path easily. Apart from that, this is the MDS context that it uses. And the other important thing is the flags. So as you can see, the flags, there are various flags that it uses, mostly related to the locks and stuff. For example, if you want to traverse this path, if the flag is set to traverse discover, we would be discovering it with all the MDSs. And if you want to traverse the path with the path locked, and if the traverse one dentry flag is set, that means the caller is expecting the dentry and similar stuff. So I'm not touching the flags related to the lock much, because in the last talk I think Venki covered that part a bit. Okay, so this is mostly it. Let's get into the code. So the forward is usually set to true in the normal, in most of the use cases. The other thing with the path traverse is we mostly hit the path traverse with when the client sends a lookup on a particular path. So there are other cases where we get the we hit the path traverse, but mostly lookup is where we hit it. The client and Getator also invokes the path traverse without the path component, but the path component meaning the Getator can invoke the path traverse only with the inode number, fill it with inode number, but not the path component. Whereas the lookup, it is expected that the base name has to be filled in the path component. So the forward is generally set to true because most of the cases we don't do discover right at the start. So if you can see, the forward is set to not discover. So if the discover flag is not set, by automatically the forward is set to true. So this flag is used if the forward is set, meaning if it's not an authoritative MDS, in such cases we use this flag to pass it to the to open that entry on the authoritative MDS or pass it to the authoritative MDSs. So yeah, this is we initially set assume that the path is not the snap ID, so it is set to the no snap. Here the client is just set from it is fetched from the MDR request, and here is where the actual thing starts. So as I mentioned in the file path, the client, when the lookup comes on a component, the client side path traversal code. For example, if the lookup comes on say the slash on the path slash dir1 dir2 and file1.txt, so the client side sends a lookup on first the root inode number, that is 1/dir1. So in the so this contains path.get inode number will fetch the inode structure for the root inode. So when we are discussing the case where the path contains the inode number of the root, base name being the dir1. So we get the inode from the inode number, we get the inode structure. So if you look into the get inode, one second, get inode of the empty cache. It's simple. So it maintains a inode map. So it calls the get inode constructing the v inode. So if you go to the get inode with the v inode, it finds it. It tries to find it in the inode map and returns if it is present in the map. So let's assume, for the sake of simplicity, that we get the inode structure for the root. So that is, so I'm assuming that it's there. So if it is not there, so there are two cases. That is, if it's a directory, if it's the inode, if the inode is of a directory, I think it will search in the foreign MDS DR. I think it will search in the other MDS. And the other case is if the MDS inode is in stray. So if the directory is deleted and if the state of that inode is stray, then I think it does traverse with the discover. So I'll not go in detail with these cases. Let's talk about the simple case first. So we'll get a hang of the code flow, and then we can handle the go into the corner cases. So we have the inode structure for the root. Um, so let's assume that it's not purging, so we don't return each I'm skipping the lock cache for now. Anything related to lock cache, mostly it will be disabled in whatever the cases I have tested. So it comes here. So it will just clear the ped entry vector if it contains any stale, and it will fill in the inode, the root inode as the current inode that it returns. But yeah, for now. So this is the for loop that where it traverses the base name component. So until now, from the parent inode number, we got the inode structure. So this is where we jump into the path component and traverse each path. So the root inode is a directory, so we are good here. And these two checks are related if the path component contains a snap their path. So I'll skip this for now. I will visit this when we are talking about the snap their path. So this is interesting here. So this is where from the inode we will pick the fragment related to that path. So here the path is dir1. So from that fragment we'll get the cdir structure. Okay. So this structure, yeah. Okay. So this is important because if that dir1, we are picking up the fragment of the dir1, and from that fragment we are fetching the cdir of that current directory. Okay, so let's assume that the cdir structure, we have no problem with the cdir structure, and we are good with it. I'll just skip through these conditions. Yeah, these two, and we, yeah. So from that cdir, we will do a lookup on that particular path. So snap ID he refers to head here because the snap their path is not involved. So in this lookup, there are two cases. One, we might hit the, sorry, uh, lookup is pretty simple. So it tries to look up for that particular base name in the cdir structure object. If it finds it, that's a hit. So we will find the entry for that particular base name. If it doesn't hit it, it's a miss, and we'll have a separate code flow for that. Let's assume that we get the entry, the lookup is successful, and we get the entry. So in that particular case, again we do some state checks if it's not purging and those stuff. If it's all good, this is related to lock. Skipping here. Yeah, so this is where we push the entry back into that return structure vector that we that is passed to the path traverse. And the other thing here is that from that entry, we also have to fetch the inode so that we return it back to the caller. So this is where from that entry we get the linkage structure. So linkage is where it maintains, for example. Yeah, so linkage structure is where it maintains whether that it has a pointer to the inode, and also whether that inode is primary, remote, or null. All this stuff is maintained in the linkage. So once we have a linkage object, from that there are a couple of checks whether it is null or stuff like that. So from that linkage, we get the inode of the base component. So this is where we get that inode. So I'm assuming the success cases here. So we got the inode. So that inode is treated as current. Uh, so in usual cases, in the lookup, there only be a parent inode number and a base component being a single path name. If it's, for example, if it's like slash dir1 dir2 followed by something, the client side only sends it as base parent inode number slash a single component of the base name. Again, look up on the parent or inode being the dir1 and the next component, like that it will send. So that is a general case with the lookup, but I think with the snap dir path traversal and in some other cases, there might be the path component contains the entire more than one component. So in those cases, we would return the entry for all of the path components. Uh, that's why the entry is a vector. So this is the inode is assigned to current. I'm skipping this step for now. Yeah, so this is, we are touching the inode. So we are updating the LRU that the inode is being touched. And if so, here we are assigning the inode of the base name component to the return value, and we are increasing the depth to check whether if the path component contains any more. In most of the lookup cases, it is not. So when it gets continued, we are getting out of the for loop. So if we get out of the for loop, it's pretty simple. This is where we get out of the for loop. So at the end of this for loop, in the success cases, we have a entry and also the inode for that particular base component. So again, there are some checks. If the authoritative MDS flag is set and it doesn't want an entry, then there are some cases. I'll not go in detail to this. And this is interesting that if it is not authoritative, if the current inode is not authoritative, then it is forwarded to the one from forwarded to the authoritative MDS. So, and the return values are like that. So one more interesting thing is that in the success case, the return value is 0. Otherwise, the return value would be 1 or 2. I think, let's guess. If it is 2, if the return value is 1, I think we'll wait. We'll add the request to the waiting queue and wait for the uh, result. If the if the return value is 2, I think we'll forward the request to the authoritative MDS. I'll confirm that once we go to the caller and explore that. So yeah, so if the code flow is if we are able to get the entry and the inode, it is treated as success, and the return value is 0. So now, if we take the lookup as an example, now the lookup comes on the parent inode being the inode number being of dir1, so and the next component. So likewise, it continues. So there are two cases I think I have missed. One is what happens if we is the entry in the lookup, right? Yeah. So if in the current directory, when we look up if we miss that entry, if that lookup is a miss, so we reach here and we check whether the cdir which we have is from the authoritative MDS, and if it is yes, and if it is in the complete state, and if there are if it's not related to snap, and it will check in its Bloom filter whether uh, if it has the path component. If it does not have, if the Bloom filter says no, then obviously it is a case of ent. So if these things, if these uh, then this is the ent case. So there is other case that if it is not authoritative, so we'll finish that. If it's not authoritative, then we'll do couple of checks with the forward and discover, and based on that, I'm not very familiar with this particular check, so I'll just skip through this checks. So yeah, if it finds it has to discover, then it will do a discover on that path. If it has to be forward, then it will check whether it's an ambiguous no MDS is having the authority on it. If that's the case, then it will add it to the waiter list and return -1. And if there is an authoritative MDS, it will forward the request for that. So this is if the dentry is not if the current MDS which is processing is not the authoritative one, it will go to this code path. If it is the authoritative one, then it declares it as, that's the ent case. So in the ent case, it does a couple of checks. So if the uh, entry vector is requested, the entry is requested, yeah, there's a couple. If the path component is not the last one, so it doesn't return the entry. So if it is if the path involves the snap dir path, then will not add a null entry for that. We just return ent. If the current directory is frozen, so sometimes the directory goes into frozen state in the situation, in the cases where the balancing happens. In those cases, I guess. So in those cases, we add it to the waiting list and return -1. Else, if this is none of these cases, we add a null entry into the CDIR. And we do necessary steps with respect to logs, and we return that entry to the caller if if the want entry flag is set. So this is the use case I've seen. For example, when you do a touch a file on the particular directory, when it reaches the last component of the path traversal, it generally adds a null entry first and returns the entry, and then again we'll look into that in detail when we go through the actual when we attach GDB and examine. So, so yeah, if the want entry flag is set, it will return that the entry here. If it is not set, yeah, it returns ent for that. One more use case is if it is an authoritative MDS and if it is not complete or any of that state, we will reach here. In that case, we will check the damaged table. So MDS maintains a damaged inode damage table. So if it is part of it, I think we'll return EIO. Apart from that, if is not complete, we will update the LRU and try to fetch the it. So the caller would get a return one, so the caller would behave appropriately. So this case is covered. Yeah, that I guess once. Yeah, I think most of the cases have touched upon. Let's go to an example and see the exact code flow. I think there will be more friendly. So here I have a attach GDB to the MDS. So this is a use case with a single MDS. So I have put a breakpoint in the path traverse. I think I had already mounted it. I will unmount and remount it to avoid the cases where it serves from the client cache. So let's do attach on. Okay, so this is what I'm issuing from the mount. So let's print the path component. So as you can see, let's also check. As you can see, the inode number is 1, that is the root inode number, and the path component is div1. So that's what I was explaining in the code walkthrough. So in the lookup, and also observe this part, if the part doesn't involve a snapdiv path, this vector will the zeroth index directly will have the base name. If it's a snapdir path, the zeroth index will have a null. Whose length would be it's a null string followed by the path component. We'll see that later. So check the backtrace BT. So so it's a lookup. So the lookup in MDS is handled by the handle client getAttr routines by having a boolean. So if his lookup is true, it's a lookup call. If it's not, it's a getAttr. So let's go through it. So all these flags are assigned. So forward is set to true. So it is checking for the MDR request, and snap ID is assigned. It is getting the client. Yeah. So here, let's print the PDN vec. As of now, it's null. Similarly, pin is also is 0. This is what we this path traversal is expected to fill. So now that we got the current inode from the inode number. So we have the this is the inode of the root. So it's not in the state of purge, so we did not go there. Log cache is not enabled. We did not go there. So yeah, so we just clearing the PDN vector if there are still, and if we are assigning the inode of the root into the pin here. Yeah, so we are now traversing the path component. So if I print, as you can see, path component is only one, that is div1. So go there. Yeah, it's a directory. Yeah, this is not equal to 0. It's not a snapdir path, so we don't go there. Yeah, here is where it picks the directory fragment of that particular path from the inode that is successful. From the directory frag which we fetch the cdir. So cdir is not null, and all these checks with, yeah, here is where the lookup happens on that particular path. So currently we are looking into the one snap ID is head. So the lookup is successful. So that's why we went inside the if condition, keeping the lock related stuff. Yeah, so here is where we are pushing that entry into the vector. And yeah, so from that entry, we are fetching the linkage structure. From that linkage structure, we get the inode of the dir1. Yeah, that, so we assign that into the current variable. So we are updating the LRU. Yeah, so def plus plus. So continue. The for loop exits here because the base component contains only one path. Yeah, we exited the for loop. So we have a couple of checks. If want auth, then if it is true. So path traverse is finished, and we return 0. Yeah, so if I hit continue, again there is a request for the path traversal on the same component, probably because, yeah, if this is from the another our read lock path pin ref, so I'll continue that because it will return pretty much the same thing. Yeah, so let's look at the, yeah, see here the inode is of the dir1. The path component is null, so this is definitely not the lookup. So if we check, it should be getattr. Yeah, so it is from the getattr and it's not lookup. So in this particular case, it is only expecting the inode structure of this particular inode number for whatsoever reason. If we go through it, it will just much follow the same thing that we saw. It gets the inode, it updates it. This path component is null, so it doesn't enter into the for loop. It just returns. So that's pretty simple. The same request again for some reason. And continue. Yeah, so let's see what is this. Yeah, so now the client sent on the next component, that is this is the inode of the dir1 and the path component is dir2. I will hit the continue button because it's pretty much follows the same thing and it returns that entry. Same again from the readlock path ref, I guess. And I think we'll get one more request. Yeah, now we have the inode for the dir2 and the path component being the file2.txt. Let's get in here. Yeah, we got the inode for that particular dir2. Inode is not null. We update the pin. Yeah, we entered into the part that depth is again 1, so there is only one component. So this is not a snapdeal path, so we won't go there. Yeah, we pick the fragment, and from that we pick the cdir. From the cdir, the next step is to look up for the file2.txt. Yeah, we would be looking up. So in this case, it is not present. I'm trying to create it. Let's see what happens. Yeah, that entry is not present. So the lookup is a miss on that particular entry. Now we are checking whether that cdir is an authority is from the authoritative MDS, and now checking whether it is complete and all that stuff. And now, so if you remember this check also contained other stuff like there is a Bloom filter check where it guarantees that the entry is not present. So now we check whether the is requested for that entry, the caller is requested for that entry. We are checking all this stuff. It's not frozen. Yeah, in this particular case, we are adding a null entry. Added a null entry for that. Let's see, and we are pushing. We are updating that entry into the vector. The want entry was not filled, so we are returning a int. Let's see what happens. So we again got it from the readlog path pin ref. Let's see what happens here. We got the inode. Here, this is fine. We entered into the flag. We got the calendar. Look up. In this case, I think we'll find the null entry that that got added in the last call. Yes, it's not urgent. Doc related stuff. I'm doing it for now. Updating the entry vector. We are trying to get the linkage from the entry. Now we have the check is null. Yeah, it's found out that the entry is null, and it is checking whether it's the last component. Yes, it is. And again, it's returning int. Now again, we got the call. Again, we got the lookup on that same thing. This time as well, we should return int. Traversal. Okay, we did not find it in the lookup. We added null again. Return int. Yeah. This time as well, we would get an int. Now this is for the client date. It will return the inode for that particular inode number. Again, the same thing. One more. Yeah, now the actual create came with the open. Now I think it will return int and then was not a snapdeal path. It got the cdir. Trying to look up for the name. I did not find that entry. Added the null entry for that particular base name. Yeah, so in this, but when the when the create request came, so I think it sets the want entry to true. So in this case, it added the null entry and doesn't return event. So break from there. And I think it would be file 2 would be created on this. I think this is the inode of that particular file 2 which just got created, I guess. Will return the inode. It found the inode. There is no path component. Return 0. Then again, yeah. So now at least we have this simple use case did not involve any corner cases, but at least it gave us a glimpse of how the client modifies the complete path into the parent inode number and the base name, and how the final component gets created when if it's a create which of a file which does not exist. We will also do a simple code walkthrough which involves a snap directory path. I already have a snap path here. Let's see. Okay, so here since I had some of the component, some of the traversal is returned from the client cache, I guess, because I did not remount, unmount and remount, or it's not from a new mount. So I'm directly getting a path traversal request on the MDS for this particular inode number. I think this is of dir1, and this is not. This is definitely not a lookup. Yeah, this will fetch the inode of that particular dir1. So I'll just do a continue. Again, same thing. Yeah, so this is interesting. So the client found out that that snap was there in the path component, and it filled in the file path structure like this. So this is the inode number of the dir1 and the path of the snap1 from the snap1 is the snap name. So this was what I was mentioning. If it involves a snap directory path, the 0th index will have a string of length 0, and the next component will have the snap name. Now let's go through this. It gets the inode of the dir1, assigns it to there. For loop, yeah, this is where we enter into the path of depth. As I showed here, the depth of length is 0, so it will go there. It identifies this as a snap dir, and assigns a snap ID of snap dir, and it also assigns the snap ID to the MDR request and increments it and continues the for loop. Now it has reached the snap1, and that's the snap name. So yeah, it's a snap dir that's got snap ID snap dir that's got updated in the last loop. Yeah, now it tries to find the snap ream for that particular this thing, and it tries to resolve the snap name and fetch the snap ID for that. So print the snap ID, there we have. So it found it, and now it gets out of the for loop, returns 0, the file one doesn't exist in the snap. Let's see. Same again. Yeah, now the part now this is the inode number of the deb1. The path is the snap name followed by the base name. This is we got the inode of the deb1. Let's go to the path comp traversal path component. We identified it as the snap there. It updates it as the snap there. Continue. We are now at the snap one. It resolves the snap name and gets the snap ID. Yes. And tries to fetch the file one is there or not. Yeah. So this is interesting. Okay. So from the current directory, we are trying to fetch the fragment and now get the flag from that fragment. Current directory is not null. Yeah, so we are trying to look up. So now we are inside the snap directory. Look up. I think from here it follows the same thing. It's a miss because the file one doesn't exist. Since it is a snap realm and the file one doesn't exist, we are not adding a null entry for that. In other cases, as we saw, we used to add it. So here we are returning event. Yeah, so this is pretty much what happens when the snap directory is involved with the path traversal. Yeah, that's mostly it. I think I also covered the use case where it is event with the same thing. Yeah, this is a basic overview of what happens with the path traversal. I'm not digged into the corner cases and stuff. Probably I will have better understanding and give one more session on it if that's required. Yeah, that's all I had. Thank you. Any questions?
Kotresh, you're talking about Bloom filter. So which part of
I'll just show you that code.
where is it implemented and what's the purpose?
1 second. There is one check which I saw. Yeah, here. So Bloom filter is a data structure. If you have if it says it's a data structure, if it when you try to find it in the Bloom filter, something, if it says no, it's a definite no. If it says yes, then it means that it might be there, it might not be there. So it's a data structure that's being used here. I did not dig into how that's get built in the MDS and stuff, but so that's the general idea of the Bloom filter. So they have this Bloom filter implemented on when you try to look up a path name on the current CD, right? So I think they populate it once they have it. So they use that to surely say if it's a event. So this is where they do this check.
Okay, so it's in the seeded data structure,
Yeah, yeah,
and its purpose is to find if the path definitely does not
yeah,
exist.
Yeah,
that's right.
Well, it's an optimization, I think. So, I mean, you don't have to, you do the underlying check only if Bloom filter gives, says that either the file is there. So it's an optimization case where if the underlying object you're trying to find doesn't exist, so Bloomfilter says it's not there, so you can trust it. Otherwise, if it says it's there, it's like you need to double check, go and walk a structure or something like that. So it's an optimization built over a linear search.
Yeah.
Okay. Yeah, the other question was about the LRU caching algorithm. And what's the, I mean, at what level is it implemented? I mean,
Okay, so I did not dig very deep into it, but a few of the data structures, a few of the objects, right? If you check the definition of that, it's inherited from the LRU. There is a base LRU class. From that, it is
okay.
inherited. Let's check that. So this, sorry, touch inode, right?
Okay.
Current, right? It's okay. If we go into current is C inode, I guess, right? 1 second. Yeah, C inode. C. The counter. Somewhere I saw LRU. Yeah, see, for example, Dentry is inherited from MDS cache object, LRU object. So I think this provides the mechanism for the LRU least recently used, maintaining that view, I guess.
Okay. Yeah, thanks. I can sub LRU object. Yeah.
Any more questions? Okay, I think, yeah. Thanks for your time, guys. Yeah, thanks. Bye.
Thanks, Kotrish. Nice talk.
Thanks. Bye. Thanks, Kotrish.